Welcome to Google DeepMind, the podcast, with me, your host, Professor Hannah Fry. Now, 2025 is coming, and so is the era of agentic AI. Although, of course, you'll have known about that months ago if you've been listening to us. So now listen in carefully as we tell you about the next thing. It's called Project Astra, and it's a research prototype that is pushing the boundaries of what might be possible with a universal AI assistant. It's an agent that is, by design, not necessarily tethered to a particular device or a screen or a keyboard. This is right at the brink of the cutting edge. And today, we get to play with it. Now, Project Astra brings together all of the things that we've spoken about in this series: memory, vision, context, reasoning, real-time interaction, and someone who can tell us a lot about all of those and how he and his team have managed to get them to work together is Greg Wayne, Director in Research at Google DeepMind. Now, Greg also happens to be one of the very first people I interviewed right at the very, very beginning of Series 1 of this podcast. Greg, welcome back.
Hello, Hannah.
Let's start at the beginning then. What is Project Astra?
Project Astra is a team and a project and a prototype aiming to build an AI assistant with eyes, ears, and a voice that's co-present with you. So it is with you in any place you are. So either through smart glasses or your phone or your computer, it can see what you're doing. It can talk to you about it.
Like a little assistant that sits on your shoulder.
Yeah, like a little parrot on your shoulder that's hanging out with you and talking to you about the world.
That's just smarter than you.
That, in some ways, yeah.
I suppose then, in a way, then that is different to like Google Assistant or Gemini.
Yeah,
it's more embedded in the world.
Yeah, so the sort of older version of a Google Assistant was kind of like a command and control system for your home or your information. Turn on this song on YouTube or something like that. And this is about being able to talk about the world. It builds on Gemini. Gemini is the intelligence underneath the hood, along with some other systems. I think it's complementary to the vision of Gemini in a way, and works with it and maybe helps shape Gemini and is also shaped by it.
Can we try it out then? Because I think this is something you sort of have to experience to understand.
Totally, yeah. Okay, I'm going to turn it back on.
Hey, Greg.
It knows you.
It does, yeah. I've had many conversations with it before.
Indeed, we have spoken previously. It is good to talk to you again.
I'm going to hand you to my friend Hannah for 1 second.
All right, it's nice to meet Hannah. I'm here whenever you need me.
Hi, Project Astra. Okay.
Hello, Hannah.
Can you guess what we're doing today?
Based on the equipment and setup, it appears you are recording a video or podcast in a studio. Is this correct?
It absolutely is. Okay, I'm going to test you on a few things, all right? Because I brought in a few objects. Is that okay?
Yeah. I am ready when you are. I look forward to seeing the objects.
Okay. All right. Let's start off. This is my favorite book, Project Astra. Can you see the book?
Yes, I can see the book. It displays a graphic with a repeating pattern, a motif known as MC, Escher's Circle Limit IV.
Can you guess what the book is?
Based on the image of the open page and the artwork on it, it appears to be Fermat's last theorem.
No. Okay, I'm so impressed. I'm so impressed. Okay, I brought in.
That's a crufty old copy.
I know it's. You can tell it's my favorite book. It's been loved. It's been very loved over many years. Okay, I'm going to try a couple of other things just to see if I can really test you. All right, let's try this. Hang on.
It's good to see you have brought out the nice furniture to complement the book. Do you require my assistance with anything else?
I have brought out the nice furniture, Project Astra. Yeah, thank you. Okay, here's what about this? Do you know what that is?
It appears to be a model of a brain.
Which hemisphere?
It is the left hemisphere of the brain model.
Wow.
Why did you say?
Unsure what
Well, I mean, I had to do a lot of mental rotation for that.
Me too. Which way round is it? Oh yeah, but got it right. Amazing. I might just try because there's a whiteboard behind you that has been there all. I've basically been looking at this for many months now. So Astra, if I show you that there, tell me what some of the drawings are on the whiteboard.
The whiteboard contains a variety of drawings, including a tree, buildings, and a series of connected lines and shapes. There are also some musical notes and text bubbles.
I'm very impressed. Let me just put this little guy back where it belongs over here. So Project Astra is still this research prototype. It's not available as a product that everyone can just download. Why demo it now? Why wouldn't you wait until it was ready?
I think it's nice to bring the public along on the journey in a way, right? I think people should get to know what's sort of being developed inside the labs, and we're giving it to more people to start playing with and start adjusting to or giving feedback about. Now it's a co-creation process where it's not only sort of some kind of thing that's being cooked up in a lab, it's also being cooked up in collaboration with a group of users, in around the world. People outside of Google. That's important too. So if we're going to make this really a helpful thing for humanity, then people need to start using it and telling us how they feel about it.
So have people been taking this out and about and trying it out in the real world?
Yeah, we've had these trusted testers, people who are using it, who are just signed up to be kind of early adopters.
What are people using it for?
People are using it for things like getting like fashion advice from Astra.
Oh, really? In what way?
Like what would match with this. So yeah, Astra is kind of just like a partner. Like, oh, what do you think about how could I have a fresher look here?
Oh wow, I mean that's a very clever parrot.
It's a very clever parrot.
But then what about hardware? I mean, at the moment, as you say, it's on your smartphone. But are we talking about like eventually in glasses?
Yeah, but not only, So I think when an earlier version of this project started, it was really trying to tease out how useful smart glasses would be if an AI was on them. So in smart glasses, it's the most kind of intimate and in some ways amazing experience. You've got this, like you feel augmented personally, like you're having a conversation with a smart version of yourself that's just sitting there and telling you whatever you want to know. But the software stack effectively is agnostic to how you're use. I mean, there's specializations for each device, but you can have it on phones or computers or VR headsets.
I was thinking as well, actually, as we were just playing around with it, there's a potential benefit for people who are partially sighted here or blind too, right?
Yeah, that's an obsession of mine. We've talked about the sort of AI as being co-present or sharing your perspective. And sometimes you want another seeing and hearing, kind of intelligence with you, but you don't always need one. So when are the cases when you want kind of a system that can see alongside you? If you see but don't understand, or if you can't see. And so that's a whole category. And there's a lot of people out there, hundreds of millions of people who have vision impairment. And what's the gold standard of help for that population? Well, it's having someone by their side who can help them out in the world. And this technology sort of is able to replicate that to a large extent. We have kind of more nascent ideas too about other kinds of disabilities. So you could imagine helping people who have difficulty scanning emotions and faces, understanding that in certain circumstances.
So people potentially with autism could use this to help.
Yeah, I wouldn't recommend it as a prescribed drug right at the moment, but I think with further development, it could definitely be. Also for training yourself, sort of, since you could work on understanding faces and have Astra give you feedback, like, hey, tell me about this. I remember, sort of on a separate topic, but when I was doing a homestay, I was learning French one summer, and I couldn't pronounce certain words, like the difference between the word for street and the word for wheel. like la rue and la rue, or I still can't do it, right? But I sat there with my like homestay brother, and I was just like trying to copy him for a while. He's just like blew me off after like a few minutes. He's like, I'm not sitting there with you. Like Astra would be infinitely patient with you and could help you with that kind of thing. Obviously memory. So we have, a system that has perfect in-session memory, we call it. So as when the camera is rolling, basically it remembers the last 10 minutes photographically. But it will also remember what you've talked about in the past. That's why it remembers I'm Greg. And probably if we turn it back on and we say, do you remember who was talking to you besides Greg the last time? It'll remember Hannah. So this could be used for people with, some cognitive impairments too. At some point. I think one of the things that we're excited about too is this idea of proactiveness. So it deciding on its own that you have a need, and then kind of channeling the response to that need without your actual need to give it a steer. So, for example, it could be a useful system for reminding you of things, going through the memories and saying, oh, don't forget, you need to pick this up on your way home or whatever.
So you're not necessarily just proactively switching it on when you want to talk to it, but it could be there in the background and then it bring up something when it thought it was appropriate.
Yeah. So the idea is like, you are going home and it's like, hey, don't forget that you need to like pick up some orange juice because you ran out this morning or whatever.
Oh, wow. Because it remembers having seen that in the morning.
Yeah, exactly. Yeah.
So, I guess at this stage, this is like painting ideas of what's possible rather.
Yeah, we don't have that yet. No, but that's the kind of thing that we could build next. Yeah.
But you can see the beginnings of it in this.
Yeah. So I could easily say, here's my fridge, and oh no, there's not much orange juice. And then I'd say, hey, what do you think I should get at the supermarket later? And I would remember that. Yeah. Amazing. But I would have to, sort of give it a bit more of a contextual.
Hold its hand a little bit more, as it were.
Yeah.
Yeah. Do you find yourself having to correct it a lot? Do you notice glitches?
Yeah. So one thing it does once in a while is it says it can't really see something that it can clearly see. And so like, you'll be reading like on a bookshelf and you'll say like, can you read the titles of the bookshelf? And it'll say like, oh no, the titles I can't make. And then you'll say something like, you'll kind of do a Jedi mind trick on it. It'll be like, yes, you can see. And it'll be like, yes, I can. And it'll then, this is sort of a weird limitation of the agreeableness is something that you can influence.
Is it like susceptible to encouragement then?
Yes. Really?
Hey, it works for humans too. A little bit of encouragement and suddenly you can do things you didn't think were possible. So how? What other kind of environments does it struggle with? What about? It's quite quiet in here. It's quite well lit. There's not lots of busyness going on. Does it work just as well in those kind of environments? Busy, noisy, dark, perhaps?
In some ways, operating in more environments is an important thing that we need to develop, in particular noise conditions. So as I said to you, Astra really does hear. It actually takes in the audio, directly converts it into a system that is the neural networks take in sound and encode them as some kind of a package of information that is processed by the language model, Gemini, directly. But the system isn't really trained to identify different voices. So it will have trouble understanding your voice versus my voice when we're talking. So if there's other bystanders who are having conversations, Astra will pick that up as potentially the user's speech. Or it actually has a system that kind of wakes up and stop and listens for a bit when there is somebody speaking with enough intensity. And it will just sort of start listening to, errant speech and kind of be confused if there's nothing directed at it. So noisy environments will confuse it.
When you say distinguish between the different voices, as in like in the kind of the waveform itself?
So there's an old problem called the cocktail problem, which is the whole problem of what's more technically known as source separation. So it's understanding one sound source from another. So if there's like a guitar and someone singing, you could isolate that into two tracks, the guitar track and the singing track. Likewise, you might want to be able to distinguish the one speaker's track and another speaker's track. So that might be possible to do in within the single modality or sense of audio. It would also be possible to do that in a multimodal sense, integrating across senses. So, for example, when I know that it's you speaking, I can also see the movement of your lips rather than the movement of someone else's lips. So ultimately, you could imagine the systems would use all sorts of cues, even to change the way they perceive a sound.
Because I guess this is in some ways the thing that makes Project Astra so difficult, but also the thing that gives it the potential, because the cocktail problem, as you say, which humans are extremely good at, you're in a cocktail party and you can hear exactly what the person next to you is saying, despite loads of voices going on all around you.
I have trouble, actually.
Actually, do you know what? Honestly, so do I.
That's why it's the problem.
But broadly speaking, humans are quite good at these things. And when you have the audio-only problem, it's really hard to solve. But because this is multimodal, because you have video, because you have audio, because you have the text language model running in the background, you do have more levers to potentially pull here.
Yeah, I think it should be able to resolve ambiguity with more context.
How about different languages? Is it only in English at the moment and only with a very clear accent?
It's mostly in English for me, but it's very multilingual. So as a function of being native audio, it knows about 20 languages with pretty high proficiency. And you can switch between languages, even in the same conversation.
So go on, give me a little demo of different languages.
Hello, Gregory. It's nice to speak with you again.
Bonjour, Astra. Comment t'appelles-tu?
Comment ça va?
Ah oui, ça va bien?
Bien, je suis contente que vous alliez bien.
Merci aussi. Qu'est-ce que tu vois maintenant?
Je vois une personne avec des cheveux roux et un chandail noir et blanc assise à une table.
Little redhead. Got that.
Ouais. Les cheveux roux. Ouais, bien sûr.
Oui.
So can you just, hang on, I did Russian in school. I can remember one remaining Russian phrase. Can you... Can you switch languages in the middle without necessarily warning it? So could I say, for example, в котором часов открывается универмаг?
You certainly could use that phrase, but what did you wish to ask about this phrase?
What does it mean?
В котором часу открывается? Means, at what time does IT open? It is asking about the opening time of the meeting.
Okay. I mean, it is. What time does the shop open, I think. But notable then that you're not saying now in English, now in French, now in Russian.
I think it's targeted to respond in the language that you started with. So actually you said something in English and then gave the Russian. I think if you'd started speaking in Russian, it would have responded in Russian, but it was thinking I'm speaking English, but I am hearing Russian. So you didn't have to change that, but if you'd just started speaking in Russian, it would have been maybe a little bit better. But
I mean, this is different though, right? I mean, from the chatbots that we have at the moment, this is this is an additional capability.
I'm actually really excited about language learning with this system, like walking around and being like, what is that? Having it teach you the same way that I was taught in school, where we would bring in objects and talk about those objects in French class to learn about stuff, being together and learning language.
I can imagine being lost in a foreign city and that being quite a helpful aid.
Exactly, yeah. And it should be able to understand other people speaking to you quite naturally too. So
if this is the thing that you're interacting with, what's actually going on underneath the hood? What are all the different components?
Yeah. So the first thing is there's an app, and that is actually gathering your video and taking in your audio through the mic and so forth. And that's connecting to a server on which there are several different kinds of neural network models.
Like what?
So there's a vision encoder and an audio encoder. There's also specialized audio systems that are just responsible for understanding when you've probably stopped speaking. Those are sitting next to the large language model, Gemini. And they are sending information from these sensory encoders directly into Gemini, which is responding. We worked together with some of the teams in Gemini also to change the Gemini model to be better at dialogue and audio processing. So we've kind of improved its ability to have audio, take an audio, and speak. When we started working with the models, they were making lots of factual errors. So we had to kind of identify ways in which we could improve their factuality while also being kind of conversational. That was one aspect of our work on Gemini. On top of all of that, though, is something called an agent. The agent is taking the video and audio in, sending it to the model. It's also calling search tools, so either Google Lens or Google Search or Google Maps when needed to respond to a query. So if you ask about the price of something, it will call search. There's also a memory system that is it's sort of part of the agent. And offline in between sessions, the memory system will summarize relevant information from the session about you and about what you've talked about in that session. So those are some of the ingredients.
I mean, I'm trying to imagine like for something that we use just to recognize a book, right? I'm trying to think of like the number of different elements that are coming into play here, because you've got the sort of the computer vision, you've got the voice recognition, you've got the large language models, you've got the Google search sort of sitting underneath it, you've got the agent layer where you're actually making decisions, and you're doing all of that with like almost no latency at all in the answers that it's giving you. I mean, this is like a phenomenally complicated thing.
Yeah, I mean, phenomenally complicated. Of course, as engineers, we come up with abstraction layers that we don't have to think about all the levels of complexity at one time. But I think overall, it's hugely complicated. The data that's going into the models is understood by very few people, and exactly why it produces the results is probably understood by no one in a sense, since it's just based on benchmarks.
Well, let me talk a little bit about the history of this, because so back in the first series of this podcast, you were a guest on the very first episode, and then you were drawing on inspiration from the animal kingdom for your research on intelligence. And specifically, there was a bird, the Western scrub jay, that you were telling us about, as a way to inspire more sophisticated memory for AI. Let me just play you a little clip of it, actually.
Having a kind of large database of things that you've done and seen that you can access and that you can use to then guide your goal-directed behavior later. I'm hungry. I would love to have some maggots right now. Where should I go find those? That's the kind of thing we would like to replicate.
Have you managed to?
Hello, Project Astra. Can you find some maggots for me?
I mean, that sounds quite a lot like your orange juice example, doesn't it?
It is a proactive memory example, yeah.
Yeah. And that's what you've done with Project Astra.
Yeah, I think that there's a sense in which like intelligence is really one thing, right? And one has a career and one is studying what intelligence is. One is taking kind of glancing hits at it, kind of like trying to understand, spar with it in one way or another. And this project maybe is the sort of strongest unification of all of the strands of research I've had in my life. Although actually it's missing a major one, which is that it's not embodied in a physical sense. It can't act in the world, which I used perhaps. I think memory, perception, these have been longstanding interests. And I think this is a way of bringing them together that people seem to also find stimulates them. They feel connected to it.
So how much of your neuroscience background did end up inspiring Project Astra?
So neuroscience is used in two ways. One is that there's a sense in which we're using neuroscience to know when we've done a good enough job, to think about like, what does memory really mean and have we achieved it yet? And it's also just a bit of a propulsion, like say, if we want something that is compatible with us, human compatible, and some ways like us, kind of maybe go towards an embodiment of intelligence that's a little bit more like us rather than kind of a straightforward text interface. For example, I have been interested in the work of Michael Tomasello, who's studies human communication by comparison to the great apes. And he's really maybe the main thinker behind this idea of for me, situated dialogue, where he talks about the kind of like the basic premise of communication as being about two individuals who are in the same place, who are directing attention in the same place, and therefore inferring goals together and then able to collaborate. And that was kind of like what we modeled in this technology.
So it's like the inspiration rather than necessarily at the kind of the theoretical level, rather than actually like directly copying the design of it.
Not for the problem solving or the engineering per se. Then I think you need to come up with different solutions that are dependent on the technology itself.
If Project Astra links to things that we were talking about, I mean, literally years ago, where did the first spark for this project come from? Like, when did it actually begin?
Yeah, so I think I know that. So Damas Hassabis, the CEO of DeepMind, kind of threw down a challenge to the company in a way, which was for us to think about what a proto artificial general intelligence was. What does that mean? A proto-artificial general intelligence is a system that if we created it and technically minded people were able to scrutinize, investigate it, use it, experience it, they would conclude that the real deal, something that is generally intelligent and a computational device, was ultimately going to arrive. It was a matter of when, not if. But that was left unspecified. So there was a lot of kind of creative thinking at the time, like, well, maybe it's this, and so forth. And some people had kind of ideas of an intelligence arising the same way that AlphaZero arose, just by interacting with the world. Other people maybe had other ideas, but my idea was very much about the sociality of intelligence. So, we are not very smart as human beings unless we learn from others, or we learn from books, which is the same as learning from others. And that was the kind of idea I had for what proto-AGI would be. Then I thought also we can unify proto-AGI with the idea of a helpful assistant whose main goal is the benefit of the humans it interacts with. So maybe those two things together gave me something of a direction to look. And then it was when I tried to think about making it ultimately very natural, I sort of moved towards thinking about video as kind of the ultimately connective fiber of the systems.
Were there big moments along the way where you had these big breakthroughs?
Where we had big breakthroughs? Yeah, I think so. There were these phases of the project. So the first phase of the project was basically a hackathon where we had 2 weeks of kind of making the first version. And we have a video from that time. And it was quite crude. But I remember Malcolm Reynolds, who's a friend and engineer here, was playing around with Astra. And he was going around an office room and saying, "What is this?" And the system would say, "A plant." And he'd say, "What kind of a plant is this?" And I would say, "A plant." It wasn't super flexible. I remember the first demo I ever saw had a 7-second latency.
So you would say, "Hi, Project Astra," or whatever it was called
What's
then.
it called? Yeah.
And then 7 seconds later it would.
Yeah. So it was very difficult to use at all because you would kind of think it had gone away, right? But it was just 7 seconds later it would come back to you. I think one of the main discoveries of the time was basically that, there's this idea of a prompt. A prompt is the instructions you give to the system about that it needs for operation. So systems like this kind of really understand language they can read, and you can say things to them like, your name is Astra. You're an intelligent, helpful AI assistant. Some of that information is inherent in the Gemini models now, but some of it's indicated in our prompt. And it wasn't really understood whether we could prompt a system that was multimodal before very well. One of the things that was kind of a mind-blowing kind of insight or realization of the time was just telling the system that it could see the world through the user's camera gave it a sense of its own perspective on things, like where the provenance of this information to it. It didn't understand that before. It was always making mistakes. Like when you'd say, what do you see? It was always giving me the wrong answer. But then when we said, like, you're a system that is an AI that is seeing through the user's camera, then it could understand why, that this camera was something it was effectively seeing, and it would answer correctly. I mean, there was a lot of work to do there, but realizing that we could effectively prompt it was maybe even though it was a different kind of a system than when we'd built before, and you could use text to prompt its understanding of sort of the situated or kind of more embodied.
That's so interesting. When the gauntlet was thrown down of create a proto-AGI, were there people expressing doubt or skepticism that something like this might have been possible?
Yeah, I mean, so it's hindsight is curious in AI because it moves so fast and people's perception of what is obvious changes so fast. I think it's like obvious to a lot of people now in some ways, which is blows my mind. I'm like, do you know the adversity, how much convincing had to happen, right?
Well, tell us, how much?
So I think from many different perspectives, people thought this was an odd thing to do. So from the perspective of, could the systems actually understand the world at all? Like, the vision systems in that era, in terms of like the number of pixels they were taking in, it was like 96 by 96 patches of image. So like for those who don't know, the minimum of our screens is like 1,000 pixels by 1,000 pixels. So, you very blurry, input to these systems. So no wonder it couldn't identify what kind of a plant it was. It barely could see, right? The fact that these systems would really know information about what they're seeing rather than just being able to identify or classify what they're seeing. So like having a deep conversation about something seemed like probably a little too far ahead. We didn't even have basic knowledge of like, the amount of data that you need to get for systems to perform at various levels.
So then, I mean, okay, if all of this seemed so absurd and yet you embarked on it anyway, were there times when you thought it wasn't going to be possible?
No. It seemed always like it would be possible. There were times that I was maybe willing to give up.
Oh, really?
Yeah, I think I think there was a slow period before Gemini where things weren't working very well, and it was hard times. I think it didn't seem like it was a fruitful line of investigation at the time for some people. But I sort of never wavered about the fact that this was definitely possible. I think I had a much sort of more obstinate, stubborn, and kind of ultimately stupid way of going about it, which was just like, if I work on this for long enough, it will definitely work.
So I heard that as part of the testing phase, you have this Project Astra room. What's going on in there? What's in the room?
There is a special room, yeah.
What's inside the special room?
We have just like all sorts of fun and games in the special room. There's a whole bar there, so Astra can help you make a drink.
Right.
There's an art gallery, so you can flash up different paintings on screens and walk around the gallery and ask questions about art.
Okay, well, let's dig into some of the stuff that's going on behind the scenes of Astra a little bit more. Latency, I think, is a really key thing. You mentioned a moment ago about the 7-second lag that you used to get. How have you actually improved that?
So it's on multiple fronts. So we've improved the actual streaming video. So it actually is sending information faster through the app. There's a sense in which these systems, although they're trained together, there's a vision system and an audio system, this language model system that is getting the information from those two things. What's called collocating them. These are kind of a technical term, but basically we're always processing images. So as the video is coming in, for example, into the vision system, it's always running as fast as it can. And then it's sitting in the same place in the same cluster of computers as is the large language model, so that it doesn't have to make a call across, a country or a continent.
What? So sorry.
So they're running
to
next
get
to
this
each
kind
other.
of real-time understanding of what's going on. You have to physically locate the computer hardware that are running these models close to each other, because that makes a difference.
Absolutely. Yeah.
Has that been the main thing then, just moving where you're actually running the models?
No, so moving where we putting the models together is one thing. Making sure that we are caching the context, so that the context of history of what the system's interacting with you is incrementally updated over time. There's this idea of doing work with native audio, which means that previous systems had a text recognition system, a speech-to-text recognition system. So they'd take in the audio, then they'd produce a transcript, then they'd call the language model, which would respond to that, and then you get a response. This system is directly getting the audio in, so it doesn't have to have that secondary system, which also takes time or produces extra latency. So actually, as a simple effect that's possible with native audio is it can understand rare words or the pronunciation of words. A rare word, although becoming not so rare anymore, name is Demisesabis. The old systems that didn't understand audio natively directly often thought I was saying Damascus. But now it knows that it's Demisesabis, and it can use context to resolve that. Like the CEO of DeepMind is Demisesabis. Another example that somebody found recently, which we have a little demo of, is distinguishing between the word scone and the word scone, which are two pronunciations of the same biscuity thing. Project Astra can actually, you say, what's the difference between scone and scone? And it will have heard that you said a different word rather than just transcribing it into the one word. Then the final one is that Kim did a lot of great work on what's called endpointing, which is a very technical term, but more or less it knows exactly when you have stopped speaking. So it's very good at sensing like, okay, the user's really done now, so I can talk. Then there's something even more sophisticated, which is that it plans a response even if you hadn't finished speaking yet. Oh. And it's speculatively planning that. So it's sort of guessing, this is what I would say, and then when it figures out that the user really has finished speaking, then it just sends it right off. So it's already done it. It's already figured out what to say before maybe even you really know that you're done speaking.
That is so interesting. Because I guess actually a lot of the time people's sentences, the important bit of their sentences, can be in the middle, and then they sort of trail off towards the end, and you can use that time for getting ready with your answer.
Yeah, pretty much that. Yeah. We talked about this stuff. We talked about that stuff three years ago, and then it seemed like that's too much, and then it kind of started to work this year.
Preemptively guessing what the answer is going to be before the conversation has got to that point.
Yeah, and it's hard. We pause for a long time in our sentences, right? So the system that we have actually has to use some quote semantic understanding. Since it also has a bit of understanding of context and the sound. It's also hearing to guess when the user's probably done.
But also the reasoning that it's doing. I mean, even separate from reasoning, whether it's finished a sentence or not. Do you think that Project Astra is capable of reasoning?
Yeah. It's primarily reasoning through its internal structure inside the neural network, sort of in an unobservable or sort of like a very complex way. Then there's the dialogue itself it's producing. So it sometimes reasons through the dialogue, so you can kind of hear it sounding out an answer. People are also developing systems that have inner speech effectively, where they're talking to themselves without talking to you. Project Astra at the moment doesn't do much of that.
But then I guess the advances that happen in the reasoning models need not be sort of like distinct from what happens in Project Astra. Like I guess the whole point of this is that it's pulling in everything so that you have this like ultimate proto-AGI, as you called it.
Yeah, and in some ways I actually hope that it motivates some maybe more vigorous work on some aspects of reasoning. So we have this great example of Bibo Shu, the product manager on Project Astra, pulled out Astra one day at lunch and was like, how many calories are on my plate? Mm-hmm. And she had a very complex, very beautifully laid out plate with like 6 types of food, like some almonds in the middle, like a pork loin over there, like some, Brussels sprouts or whatever. And it was like, oh, kind of waffled a little bit. But then she said, keep a running total, and how many are in these, Brussels sprouts? And it was like, well, that's 7 Brussels sprouts. Therefore, it's this many calories. And then, okay, now add the pork loin. One of the things that was quite notable to me was that Bibo was hand-holding. It's, thinking, as you said, it needs a little guidance sometimes. But I don't think that we're very far off from a system that itself would just say, well, I see there are 7 almonds over there, this many Brussels sprouts, there's a pork loin, all those together are such and such. So I think it's, in some sense, it's not good at that stuff because we just haven't ever tried to build a system that could reason about that stuff.
Now, I want to talk to you a bit more about memory. On that point about the things that it's sort of recalling and keeping in its mind, as it were, if you'll forgive the anthropomorphism. I know that back at Google I.O., this could remember what happened in the last 45 seconds, right? And now you've increased that time. You can do 10 minutes now, right?
Yeah, it's about 10 minutes. Yeah, actually, it's a little bit longer in some ways, but 10 minutes is maybe what it should do on the 10.
What makes 10 minutes the limit?
Yeah, so it's got basically a raw record of the last 10 minutes of video. It works at about 1 frame per second, so it's got basically a stack of all the frames over time and all the audio that came in between those frames. So for the last 600 frames or something like that. The limits are really about the memory on the chips, I think. That hasn't scaled very much, I think, in the last decade or something like that, the amount of this sort of fast active memory.
But so at the moment, then it is effectively acting like a video recorder, as it were, keeping an actual record of everything that's happened in the previous 10 minutes.
Yeah. I mean, it's quite active. It's able to use that information right away. There's also a sort of a secondary system, which is when you shut turn the system off, it will then take that conversation and summarize it and pull out relevant facts.
The most important bits.
Yeah, and it uses its own discretion to figure out what that is.
To like extract the gist of it, as it were.
Yeah.
But at the moment, I mean, one thing that it can do is recall important things from recent interactions, can it?
Yeah, it's kind of got sort of a two-stream memory. So it's got a memory that is both about you as a person. It's got a kind of it's developing a kind of an understanding of you. It's effectively taking notes like, oh, they like ice cream. That's chocolate ice cream or whatever, and that'll be like a kind of a list of things it's discovered about you. And that's actually updated after every session too. So suppose you say, you know what, I actually have decided that I don't like ice cream anymore. I really like cake. So like, forget that I liked ice cream. It will then say, user, says they no longer like ice cream and they like cake. And those things are like kind of a stationary or static understanding of who you are effectively, or what you like, your preferences. Then there's also like this kind of conversational summary that's like, on Tuesday at 8:50, like we talked about this game of chess.
But then how does it decide which bit goes in which? Like, how does it decide what's important enough to be a thing about you that it remembers?
So it's got heuristics. These systems actually are given heuristics. So a heuristic is basically a rule of thumb for what to remember. So one heuristic it uses is, and we've told it to, is if you ask it to remember something, it should definitely remember that. It's a pretty clear one. So, if I say, remember my door code, like it will do that. Because it will understand that's an instruction of relevance. Otherwise, it takes a best guess. It tries to say, it's sort of saying, has the user expressed any preferences that are interesting or that are different from the ones that the user has already expressed? And then it'll kind of update based on that.
Well, let's talk about some of the privacy concerns here then. How do you mitigate against some of those privacy concerns?
Right. So I think one of the major standards is that of consent. The users have access to their previously recorded data, and they can delete it or see what is stored. Every time you delete something, it reconstitutes its whole knowledge of you.
Oh.
It goes through the whole process of summarizing things it knows about you anew.
So the answer then, I guess, is that the user ends up having some control over what it knows about it, about them, rather.
Yeah.
But actually, so in this podcast, a few episodes ago, we got to talk to Yason Gabriel, who's this ethicist at DeepMind. He's amazing. And he was telling us about the ethics of AI assistants and how they should be shaped in order to take into account lots of these difficult questions. How much has his work fed into what you've come up with Astra?
We just fed his 243-page report into Astra, and Astra said, "Okay, I got it."
Did you?
No, I wish. I think we've spoken a lot with Yasan, and we've done a lot of work with a team that he's part of, and they've been investigating both the model and the agent as the whole, exploring kind of what it might do in different circumstances. Also working with some external red teamers who maybe have fewer preconceptions and might do more different kinds of adversarial attacks on the system. We also have a layer of safety filters. I mean, this is for user harms or for example, if you say certain things to it or show it pornography, for example, it will kind of trigger these filters and not respond to that. It'll also trigger on its own speech, so it can't say certain things, although they trigger very infrequently anyway. But I don't know. Yeah, I think that the range of issues is quite broad. Fortunately, we still have some time to figure stuff out.
Okay, so what then are your next priorities then? Over the next few months, what were the main things you're going to be working on?
I'm very interested in something called proactive video work. So that is to say a system that can not only respond when you speak, but can also help you in an ongoing sense. So for example, that's part of the visual interpreter for the blind problem. So you're walking around, you can't see, it will say, oh, watch out for the table over there. It can guide you in an ongoing sense. We're also doing a lot of work on more audio output, what's called full duplex. So it will process both it'll hear and speak at the same time, which could be potentially annoying. It could interrupt you. but it's also more natural conversation. As you're talking, I might say, and that's listening and talking at the same time. It's part of language to confirm. More on reasoning, as you said. More deep kinds of memory. Reflection of certain kinds. When it calls tools, to be able to do deeper inquiries and research with tools. Yeah, there's just so many things to do better.
Well, thank you very much for joining us, Greg.
Thank you, Hannah.
It is strange how quickly our expectations change about AI. I don't know if you remember what Oriel said in our last episode. He said if someone had told him 5 years ago the things that would be possible, he would think that we were already on the path to AGI. And yet here we have this prototype of a multimodal agent. It's one that can see, that can hear, that has memory and context and reasoning and multilingual real-time conversation. This is an agent that could, at least in theory, accompany you on your day-to-day, enhancing your knowledge, supporting people with disabilities, and augmenting our skills. Now, of course, AGI, it isn't. But it definitely feels like we are a significant leap from the kinds of systems that we were talking about even 2 years ago. Thank you so much for joining us for this series of Google DeepMind, the podcast. We are going to take a break from here, but if you want to catch up on any of our previous episodes, then there is a whole array of deliciously nerdy AI conversational delights in our back catalogue for you to enjoy. Just find them on YouTube or wherever you get your podcasts.